Hey everybody, welcome back to Philosophy 180, Logic and Language. This video is on section 1.3 in your textbook on deduction and induction. And really, I just hope that you get these two ideas straight. Most of you probably already know the difference between deduction and induction, or you know it casually. I just want you to lock down your understanding of that distinction. Again, just like I said in the first video, the stuff in the first part of this class, it's not rocket science, but it's very important that you have very clear ideas of these basic concepts going forward, because the material coming later really does get a lot more difficult. And the clearer you are and the more automatic this early stuff is, the better off you're going to be later on. So, what we're talking about today, obviously, is deduction and induction. Clear, simple distinction. Just get it in your head and try not to lose it. Deduction. In deduction, it is impossible for a conclusion to be false if the premises offered for it are true. I'll say that again. In deduction, if the premises are true, it is impossible for the conclusion to be false. So deduction and induction, which we'll get to in a minute, describes a structure or a type of argument. And the chapter goes on to talk about various forms of deduction, various forms of induction. And so if this idea of impossibility just strikes you as strange, just read on and you'll see what the book is getting at here. But the important thing right now is that you understand the definition. To call an argument deductive means if you can establish the truth of the premises, that it is impossible for the conclusion to be false. So deduction operates with certainty. And it has to do with the structure of the argument that affords you that kind of certainty. A lot of the formal logic we're going to do, most of the formal logic we're going to do in the latter part of the class is going to be working with and analyzing deductive forms. So you need to sort of get straight on this. In deduction, if the premises are true, the conclusion is true. It's impossible for it to be otherwise. Induction. If the premises are true, it's probable that the conclusion is true. But it is not impossible for the conclusion to be false. So in deduction, the relationship between premises and conclusion, we're going for certainty. In induction, just the form of the argument, the way it's structured, the way it works, what we have is probability. Now, there are several forms of deduction in this section 1.3 that you should look at and learn. The more of the forms you understand and the more you can see what they have in common, the clearer deduction is going to be to you. The forms that you're given are mathematics. So here's just one quick example of that. If you say, I put 3 stones into an empty bag, and my sister put 4 stones into the same bag, therefore there are 7 stones in that bag. That's a deductive argument. If the premises are true, the bag was empty, I put 3 stones in it, my sister put 4 stones in it, then the conclusion has to be true. So that's one deductive form, and it's called mathematics, a mathematical form. There are others. I'm going to let you guys read these on your own. There's definition is a deductive form. Categorical syllogism. You guys need to think through this one. We're going to be dealing with those a lot going forward. Hypothetical syllogism, disjunctive syllogism. So I'm not going to go through those forms right now. We'll deal with a lot of syllogisms later. But look at all of these. Try to see what they have in common. Try to understand what distinguishes them as various forms. But know that these are forms that offer the certainty of the conclusion if the premises are true. That's what makes them deductive. Likewise, there are a bunch of inductive forms in this chapter. Prediction, like have you ever noticed that the weatherman says there's a 100% chance of rain next week? Well, if it's 100%, in what sense is that a chance, right? Seems like that's a certainty. But it's not, because all the weatherman can do is use inductive logic. He can say, every time these conditions have come together in the past, it has rained. Therefore, we predict that it will rain. So even though they've got 100% of their data suggest what's going to happen in the future, we can't do deductions about the future. We can only do induction about the future. So predictions are always inductive. Analogies, where you liken one thing to another, always inductive. Generalizations, appeals to authority, signs, and causal inference. Like the causal inference is sort of a where there's smoke, there's fire kind of thing. All of these are inductive forms. There's nothing wrong with induction. This is important. There are things that you can only know inductively. Think of the weatherman. That doesn't mean that the weatherman's logic is faulty or subpar or something. It's just the nature of that kind of argument to operate in the realm of probability rather than the realm of certainty. In fact, I would argue that most interesting things operate in this realm instead of that realm. Maybe we can talk about that some other time. But for now, this is the distinction you have to have straight. In a deduction, if the premises are true, the conclusion is certainly true. In an induction, if the premises are true, the conclusion is probably true. And that's all there is to it.